Uh, and hello everyone. So my name is Çise Mıdoğlu. I recently defended my master's thesis from Thapathali campus at the Institute of Engineering, Tribhuvan University, Nepal. The paper I will be presenting today is titled Assisting Soccer Game Summarization via Audio Intensity Analysis of Game Highlights. So this work is a collaboration with the Simula Metropolitan Center for Digital Engineering, SimulaMet, Norway, as a part of my master's thesis. So let me begin. So it is well known that soccer is the most popular sport around the globe. So it's shown in the figure. So during a live soccer game, so there are multiple people in the tagging center who are constantly working to tag video frames from the soccer broadcast pipeline, and they are responsible for all those instant event replays, score updates, and highlight videos that come to us from the football field. So recently, we can see increased interest as well as publications in event detection, player tracking, and player identification. Given that it is quite complex to automate summarization due to its subjective nature, there have been limited progress in the automated generation of abstractive textual summaries in both sports industry and research. Therefore, my thesis was around automating the summary pipeline that can consume existing multimodal data from the broadcast pipeline, including audio, spoken text by commentators, and unstructured captions. We are also interested to see if the model can handle various constraints like length constraints and subjectivity in the summary. So this particular work is a follow-up of our previous paper, Soccer Game Summarization using Audio Commentary, Metadata, and Captions, published very recently at NARSOM at ACM Multimedia 2022, where we talked about a multimodal summarization pipeline. So this pipeline can handle multiple inputs, game audio, game meta, that is structured game event information, and captions. This is unstructured game information. So multiple modules here, they can utilize either of those input combinations to generate a summary. So one of the modules used there was audio priority filter. It utilized the audio of game event to select important events and generate summary. So it was there. So this is the audio based dashboard from our previous work. And this struck the idea of doing intensity analysis. So we had calculated RMS audio intensity of various events, and it was seeing that interesting events were always at the top. That means interesting events like goal event, shots event, and penalty event, they have highest audio intensity. So we decided to do analysis over whole data set. So this is what this presentation is about. The question this work has been inspired by is whether an audio intensity level is really useful to filter important events. The question can also be rephrased as, can audio level properly catch the excitement of the audience in the game field? Does the order of audio intensity correlate with the importance of event? So for that, we would like to see if there is a statistically significant difference in audio intensity between different action events. So we are also interested to see if audio intensity between home and away team is different. Likewise, the intensity between first and second half. So also the frequency composition of audio during different events can be interesting to see. So we'll explore this. To answer the research question, we explored two different audio analysis methods. The first one is time domain based. So this is also called intensity based or RMS based. So in the frequency domain, we performed wavelet analysis on the audio signal. So the experiments are performed on public SoccerNet game dataset. So this contains football game videos and action event data. So we'll see like what this action event data look like later. So this work doesn't formulate any new or novel method for audio analysis. Neither we build any dataset. So we used existing audio analysis method and existing game dataset containing soccer game videos. But the novelty of this work is the exploration of audio intensities during game event from the soccer summarization perspective. It is also not that we are the first one to use audio for game summarization, but we believe that this is the first work to analyze audio intensity on a larger soccer dataset with 500 game videos and show its relevance to summarization. In sports, video is the primary source used for analytics. The current trend is on using computer vision methods for video understanding, obviously. So we can see interesting works in direction on utilizing process structured event data with richer context information. So using structured event information requires relatively fewer resources when used for downstream tracks. For soccer game summarization, text, image, audio, and videos are candidates that can be used as input for summarization. So different papers point out that current state-of-art approaches are very far from being useful for the industry. So model fusion with different input modalities is explored for action recognition and event categorization in games. So audio have been intensively used for years from a summarization perspective. So classical approaches before all these machine learning and convolution neural networks, they used audio characteristics to find highlight points, extract goal events, and even find referee whistle points. So after the advent of machine learning and CNNs, the community were more focused on using computer vision methods for event recognition. So later it was realized that utilizing audio information along with videos feature can give good result. So multimodal summarization framework were proposed for sport video summarization. Event understanding was also fruitful with audio and visual features. It was found that game's level of excitement was better characterized when audio data was also utilized along with other information. So audio features when added to video-only based deep learning architecture gave significant improvement with such fusion in literacies. So to calculate the excitement of the audience during the game, we used a very simple root mean square analysis. So this is also called RMS. So this is frequently used. So which is simply the arithmetic mean of squares of group of audio frames. So as frequency spectrogram provide more precise depiction of energy across time, we use frequency domain intensity or frequency component and use frequency domain equivalence of this formula as per Parseval's theorem. So we use this to calculate RMS. For frequency analysis, we perform wavelet analysis of audio signal. So wavelet analysis is alternative to the very popular windowed Fourier transform that also yields two-dimensional plot. I'll show that plot later. So it shows the strength of variations as function of both period or frequency and time. So wavelet analysis is very useful. So we chose the popular Morlet wavelet for this purpose. The beauty of this wavelet is that we can vary the width of this wavelet and perform analysis over varying period or frequency. So higher period means higher frequency. So this is it. So as I already mentioned, we use the popular SoccerNet dataset, contains videos as well as timestamp game action information. So this is what it look like. So there is video and there is associated information like this, and there is game time. So this is timestamp and there is information. For example, for a goal event, there is a timestamp. So we use this timestamp to get RMS audio level from the audio in the video when the event occurred. So this is what we did for the data. So this is the result of our root mean square analysis on large game video. So this plot sums that result. So it is seen that important events have higher RMS. So in the right hand side, there is goal event. So there are shots and penalty event. So the order of importance event as per the analysis is goal, penalty, shots, card events, and so on. So this order almost matches the priority rules used by static summarization pipeline. So therefore, from this, we can conclude that audio RMS intensity can be a good candidate as a filter model component in the game summarization pipeline. Moving on. So this plot shows the difference between the audio intensity of home and away team. So the purple one is away team and the blue is home team. So for all the events, we can see that audio intensity in the audience is more when the events are of the home team. So this is it sounds very trivial to us because when the event is of home team, there will be more people to cheer. So might be the intensity is larger due to that reason. So this is shown by this data. However, the difference in RMS is not statistically significant between events in the first half and second half. This means that intensity of audio is almost equal in both first half as well as second half. So we cannot find a statistically significant difference between those two halves. So to validate the findings statistically, we performed a one-way ANOVA test, so which is used to determine whether or not there is some statistically significance between the means of independent groups. So it was seen that different events have statistically significant intensity. So this is seen by this F value. So it has high F value. That means, so these are the events are very different to each other. Also the home and away team. So this host can be either home or away. So they also have statistically significant audio characteristics. So higher F value. However, the event from different half, either first or second halves, they have very similar characteristics and they are not very distinct. So to explore further, we also check the combination of these three variables and the results are tabulated. So they depict the similar findings. So moving on to the wavelet analysis. So for wavelet analysis, we took a 1 second audio time series after each event. So this is in time domain. And we perform Morlet wavelet analysis of varying width to give this wavelet power spectrum. So this figure, you can see that there is varying scale or width or frequency. So we start from 2 and like we double it, 2, 4, 8, 16. So these are the scales. The increasing means the increasing frequency. So we want to know what is the power spectrum across various scale. So it is the equivalent power spectrum. So for different scale, we have different intensities or power can be visualized in this global wavelet spectrum. So this figure shows that in higher scale or higher frequency, there is higher power. So this is what we can see from this. Now applying on whole data set. So this is the power distribution across wavelet scale for the 5 distinct events. So short event, offside event, goal, red card, and penalty event. So we can see that each event have distinct signature across wavelet scales. So this is increasing wavelet scale for each group. And for instance, the power scale 32. So this starts from 2, 2, 4, 6, 8, 32, the largest one. So this is the largest one. So the power scale of 32 was distinctly higher for red card event when compared to other type of events. So you can see from this. So also in these three, short, offside, and goal event, the scale 32 and 128 are significantly higher when compared to other.
Mr. Sushant, you have only 2 minutes remaining.
Yes, here I'm almost at the end. So from this result, we found that different event have significantly different audio intensity as well as frequency component. So event related to home team have higher intensity than away team. However, the intensity in both half wasn't found to be statistically different. Also, different value signature were found for different audio event, which would be due to variation of sound like audience sharing, referee whistles, instrument playing after different events, etc. across different events. So to sum up, this work explore the audio intensity analysis of game event from a game summarization perspective. It was seen the RMS-based audio filter can capture fan excitement such that they can be good enough to be used for filtering the events that look interesting to the audience. So this method, although looks very simple to implement and calculate, it is very effective when used as a filter module as part of game summarization pipeline. So with this, I am at the end of my presentation. So the audio visualization dashboard that I talked about that calculates and visualize the RMS intensity has been implemented in open source at Simula's GitHub repository as shown on the screen. So you can scan the QR to access that. So thank you all for your attention. Now the floor should be open for questions.
I would like to request if there is any question from floor or other co-presenters or others. Okay, if not, then I have probably it's not a question, but the first one I would like to provide suggestion to Sushant. Your work was phenomenal, very excellent, and the work that you have done with the sort of type of research and validation that you have conducted, it's excellent. But still, you were mentioning a couple of times the thesis, this thesis. Whenever you are making presentation on conference, you don't have to say that. You know, it's better to say in this particular research that we have done this. You don't have to mention it as thesis, because the same thesis work can be can produce a couple of papers in the days to come. So it's my just one suggestion to you. And I would like to let's say what are the extension or additional research someone else would like to continue on your work? What will be your recommendation?
Thank you for your suggestions and question, Dr. Maltimasina sir. So as I mentioned that this work is an extension of the work that has been previously conducted. So it is related to summarization. So this particular is just an analysis of the audio intensity level. So this is a part of the summarization pipeline. So there are lots of work that can be done in summarization. So summarization is almost related to natural language understanding. So it is very complex, the current state of art. So there are lots of things that can be done. So with the new models, machine learning models and transformers, so that they can improve the summarization. So particularly speaking about the soccer game summarization, there are lots of events in a particular game videos. So it almost like there will be lots of data to process. So it goes to long video summarization theme. So long video summarization, long text summarization models can be used to summarize the game data and produce like summary that is very alike like the one produced by human summarizers. So I think that direction would be very interesting to explore.
Okay,
not
just I would like to query, you know, let's say one of the researcher or like you previously might be making query on, you know, whatever on your work based on inspiration from your work. Someone would like to make, let's say, some marketing or some typical application of this sort of as you have shown on your slide number 17, the power distribution versus the event type, right? So maybe they might be making some sort of, let's say, this particular event has got this much appreciation from the spectators, right? So maybe from the marketing perspective, it might be a little bit of gimmicks, adding, it's not from the source to destination, rather from reverse way, I'm thinking. If someone would like to do the research on this one, what will be your suggestion, let's say, as per your result, based upon your result?
Yeah, for example, like this information can be very useful to other from the marketing or advertisement perspective. For example, like if I want to put some advertisement in the stadium, then I would like to see where the audience are interested in like around which event should the audience they will be willing to watch the information. So I think that can be useful for such thing. So the power spectrum and the interest of audience. I think does that answer the question?
No, that you have shown on the slide number 17. Different events have produced that the different levels of powers, right? So if I would like to, let's say, go from the back, how much the power from that I am trying to summarize, or let's say automatically make it define it as an which particular estimate which particular event it might be. So the later from the marketing perspective, someone would like to make this particular penalty event versus this goal event, or some other type of thing. So how much, what's the chance of making mistake or error going from reverse, what you have shown? Of course, you're from the forward to backward, forward to result, right? But I'm thinking about from the reverse to forward.
So you mean, like, for example, we have lots of events, and we try to guess
yes,
which should have the higher power.
Yeah.
So I think that this is very trivial. The events that are interesting to audience are like goal event, penalty event, and like card events. So this is like we also in other work we have also seen that like people have explored like what kind of event like triggers audience. So these are obviously the goal, shots, and like penalty event. So if they know that information, then like this information, like this graph should be very trivial to them. They would obviously know like which event would have higher power.
So you mean to say even if we going from back, then it will not be that much difficult, and it will produce the very good accuracy, right? As per your experimentation result. Okay, I think it's excellent. Okay, thank you very much for your excellent presentation, and thank you.
Thank you, sir. Thank you, everyone.